Hi children, welcome. Welcome once again to another chemistry class. Hope all of you are doing good, right? Yes. Today we are going to discuss some important questions from the chapter States of Matter. That is the 5th chapter, States of Matter. Can we start? Ready? Yes. Let's start. Question number 1. First question we have. Given van der Waals constants for some gases, ammonia 4.17, hydrogen 0.244, oxygen 1.36, and carbon dioxide 3.59. Which of the following gases is most easily liquefied? Most easily liquefied. See, liquefaction tendency depends on intermolecular attraction. Intermolecular attraction can be understood by the van der Waals constant A. Van der Waals constant A is a measure of intermolecular attraction. Greater the A value, greater the molecular attraction. Which is having greater A value? Ammonia. Ammonia is the answer. And all of you know ammonia is a easily liquefiable gas. And that is observed as a measure of A value for van der Waals constant value for ammonia here. Greater the A value, greater the intermolecular attraction, easier the liquefaction. So which is tough to liquefy? Which is tough to liquefy? No doubt hydrogen 0.244. Yes. Next question. The correction factor A to the ideal gas equation correspond to, just now we have commented, which one? The forces of attraction between gas molecules. Option 4. Next. A gas at 350 Kelvin 15 bar has a molar volume 20% smaller than that of the ideal gas. So real volume less than ideal volume. Under the same condition, correct option about the gas and its compressibility factor Z is. So you have to tell what is the character of Z. Is it less than 1, greater than 1? You have to tell whether it is attractive force or repulsive force dominant. Yes, simple aspect. You know the compressibility factor Z is equal to V real by V ideal. You have learned. So V real by V ideal, that is compressibility factor. Here it is commented that V real is less than V ideal. You see the question, 20% smaller. So V real is less than V ideal. Hence, Z is less than 1. This is less than this. So Z is less than 1. So you will go for Z less than 1. Z less than 1, there are how many choices? There are 2 choices. So these are out, right? And now Z less than 1 means, you might have seen the graph in the NCERT textbooks given. The molecules like ammonia, carbon dioxide, etc. Z less than 1 coming down because of greater molecular attraction. That means the attractive forces are dominant. Attractive forces are dominant. Answer is option 2. Here it is given. Repulsive forces are dominant. Z less than 1 means in the diagram it's going Z less than negative side. I mean Z less than 1. It's happening because of greater molecular attraction. The attractive forces are dominant. Well explained in the NCERT text. Read and understand. Line by line of NCERT. Okay. Next question. Answer is option 2. Next one. A bottle of cold drink contains 200 ml of liquid in which CO2 is 0.1 molar. Suppose CO2 behaves like an ideal gas. The volume dissolved CO2 at STP is. You see, 0.1 molar. 0.1 molar means 0.1 mole per liter. So how much in 200 ml? How much in 200 ml? You see that 0.1 mole per liter. So how much in 200 ml? In 200 ml it is 0.02 mole. In 100 ml it is 0.01 mole. 0.1 molar means 0.1 mole in 1000 ml. So in 100 ml 0.01 mole. In 200 ml 0.02 mole. 0.02 mole means what is the volume? Number of moles into molar volume 22.7. So 0.02 into 22.7, you will get your answer 0.454. Option D as the correct answer. Hope it is clear. Right? Next. A bottle of dry ammonia and a bottle of hydrogen chloride connected through a long tube are opened simultaneously at both ends. The white ammonium chloride ring first formed will be. White ammonium chloride first formed will be. You see, under identical condition, you have ammonia in a bottle which is connected through a narrow tube with another bottle containing HCl, and there are valves here. You are opening the valve simultaneously. When you open the valve, ammonia will come out, HCl will come out. At what point you will get white fume? At first. Please understand the rate of diffusion. The rate of diffusion of the gas is inversely proportional to square root of density. That is inversely proportional to molar mass. So molar mass and rate of diffusion are inversely related. Here molar mass 17, here molar mass 36.5. So here the molar mass is greater, density is greater, rate of diffusion is greater. Rate of diffusion is lower. So what will happen? When you open it, by the time HCl come out, ammonia might have reached here. So you get white fume at this point. This is having a lower molar mass, so higher rate of diffusion. So as ammonia, when you open the valve simultaneously, both come out, ammonia comes fast. HCl by the time come out, ammonia might have reached here. And you get a white fume at that point. So what is the answer? Which option? At the center of the tube? No. Near the hydrogen chloride bottle. That is the answer. You get a white fume initially near the HCl bottle because ammonia moves fast. The rate of diffusion of ammonia is fast than HCl. Graham's law of diffusion. Okay. Next question. Option B. The rate of diffusion of SO2 and O2 are in the ratio. Once again, rate of diffusion of SO2 and O2 is equal to molar mass of O2 by molar mass of SO2. എത്രയാടാ ഓപ്ഷൻ കണ്ടുപിടിക്കാം? 32 divided by 64. That is root 1 by 2. Root 1 by 2. That is 1 by root 2. Option D is the correct answer. Rate of diffusion inversely proportional to molar mass. That is R1 by R2 is equal to root of M2 by M1. That's all. Over. What is the molar mass of oxygen? 32. What is the molar mass of sulfur dioxide? 64. That's all. Option D. Next. A balloon weighing 50 kg filled with 685.2 kg of helium at 1 atm 25 degrees Celsius. If it can displace 5108 kg of air, what will be its payload? Payload. We are not learning in the textual content of states of matter, but there is a question in the NCERT exercise part. Go through. Payload is nothing but the mass of gas, mass of air displaced by the mass of, minus the mass of balloon. That is what called a payload. Payload means mass of air displaced. Imagine you are inflating an air. There will be certain mass of air displaced. The mass of air displaced minus the mass of balloon. That is called a payload. So how to calculate? Payload is nothing but mass of air displaced minus mass of balloon. What is the mass of air displaced? 5108. What is the mass of the balloon? This much. Is it that much? No, you have to add this also. This is mass of helium inside the balloon and this is the mass of material of the balloon. So it is 685 plus 50. Subtract it from that, you get your answer. 4372 option A. There may be a close figure. If you don't add that 50 also, there may be some mistake sometimes. The total mass of the balloon, it carry the air inside, helium, mass of helium plus the material mass of balloon. That is the total mass of the balloon which has been inflated, which is displacing that much mass of air. So subtracting that you get payload. Okay, next. Gaseous mixture of helium, oxygen found to have density 0.518 gram per atm cube at 25 degrees Celsius, 720 mm mercury. The percentage by mass of helium in the mixture is percentage by mass of helium in the mixture, mass of helium by total mass into 100, mass of helium by total mass into 100. That will be the percentage mass. How do you get the total? How do you get the mass? You see density given D is equal to Pm by RT, you have learned. Therefore, M is equal to dRT by M, dRT by P. Density given, R you know, temperature given, pressure 720 mm. You have to convert into ATM, 720 by 760. You will get molar mass 13.37. That is the molar mass of the mixture. That is the molar mass of the mixture. From that, let the mole fraction of helium X, then the mole fraction of oxygen 1 minus X. So X be the mole fraction of helium, 1 minus X will be the mole fraction of oxygen. Now you can equate. The total molar mass of mixture is equal to X into helium plus 1 minus X into oxygen. Thereby you can get X. Once you get X, you are getting mass of helium. What is mass of helium? X into 4. What is the total mass? Mass of helium plus mass of oxygen into 100, you will get the percentage. So mole fraction, how much you are getting? 0.66 something you are getting. Hope you understand. Right? So the mass of helium will be, mass fraction will be 0.666 into 4. Now what is the total mass? Helium plus oxygen. So mass of helium by total mass into 100 will take you to the answer. Hope it is clear. So first find the molar mass of the mixture. Then find the number of moles fractions of helium and oxygen. And if you get that, you get your answer. Okay. Next. The temperature at which average velocity of O2 molecule equal to RMS velocity at 27 degrees Celsius. Temperature at which average velocity becomes equal to RMS velocity. Most probable velocity, average velocity, RMS velocity. Equations you have to by heart. Most probable velocity root of 2RT by M. Average velocity root of 8RT by pi M. RMS velocity root of 3RT by M. If you know that, you get your answer. It's as simple as that. You see that at what temperature the two velocities becomes equal. This is average velocity root of 8RT by pi M. This is RMS velocity root of 3RT by M. And now this temperature we need to evaluate. That temperature we need to find. So root of 8RT by pi M is equal to root of 3RT by M. Now root everything cancels. M cancels, R cancels. So it is root of 8T by pi equal to root of 3T. 3 into temperature. Root cancels, you get what is T. T is equal to 3 into 300 into 3 into 300 into pi divided by 8. You get your answer 353.4 Kelvin. That is 80 degrees Celsius. 80.4 degrees Celsius. Answer required is in degrees Celsius. I think it is clear. Right? Knowing that formula, over. Next. An evacuated glass vessel weighs 50 gram when empty. 148 gram when filled with liquid of density 0.98 gram per ml and 50.5 gram when filled with an ideal gas 760 mm 300 Kelvin. Molecular mass of the gas is, molecular mass of the gas is, molecular mass you can calculate by assuming ideal behavior. PV is equal to nRT, PV is equal to mRT by m. You can find the molar mass. Right? Yes. How to calculate? This is the equation. PV is equal to WRT by m. Therefore, m is equal to WRT by PV. M is equal to WRT by PV. Now, what is weight? What is the weight of the gas? 0.5. How do you get a 0.5? How do you get a 0.5? When filled with ideal gas, the weight is 50.5. The vessel weight is 50. See, weight of the cylinder is 50. When filled with the gas, 50.5. So, what is the mass of the gas? 0.5. Okay. So, that is the mass of the gas. R value, you know. Temperature given or not? Temperature given, 300 Kelvin. Now, what is the pressure? 760 mm, that is 180 m. 760 by 760, 180 m. Now, what is the volume? What is the volume of the vessel? Volume of the vessel you have to calculate, for which density is given. For which density is given? Volume of the vessel is equal to, see, it is commented that vessel is filled with a liquid. That vessel is filled with a liquid of density 0.98 gram per ml. When it is filled with that liquid, the weight of the vessel is 148. See, you are given with the vessel. In that vessel you are taking the gas. You have to know the volume of that vessel. How to know? For which a data is given. That vessel, when filled with a liquid of density 0.98 gram per ml, having a weight 148. So what is the weight of the liquid? What is the weight of the liquid? 148. 148 liquid with vessel. So what is the weight of the liquid? 148 minus 50, because the vessel weight is 50. So mass of the liquid, when you fill in that, it is 98 gram. So what is the volume of the liquid? Mass by density. What is the mass of the liquid? 98. How do you got? Total weight is 148. Mass of the vessel is 50. Subtract, you get 98. So what is the volume of the liquid? Mass by density, 98 by 0.98. You are getting 100 ml. This is the volume of the liquid. Volume of the liquid is equal to volume of the vessel. Volume of the liquid is equal to volume of the vessel, because that vessel you are filling with the liquid. So volume of that liquid is equal to volume of the vessel. And that volume of the vessel we need here. And that we need in liters. That we need in liters. Isn't it? So 100 ml. 100 ml volume means 100 by 1000 milliliters. Sorry, liters. So it will be 0.1 liters. 100 by 1000. It will be 0.1 liters. So it is mass of the gas, R value, temperature, pressure and volume of the vessel. Volume of the gas. Volume of the vessel means volume of the gas. Volume of the vessel, volume of the gas, 100 ml. 100 ml means 0.1 liters. Verify whether you are getting 123 option D or not. Okay. So by applying ideal gas equation, you can find the molecular mass. To know the molecular mass, you must know the mass of the gas, R value, temperature, pressure, volume. Mass of the gas, 50.5 minus 50. That is the mass of the gas. Now, volume of the gas, for which it is commended to be that vessel filled with a liquid, total mass becomes 148. Therefore, mass of the liquid will be 148 minus mass of the vessel, 98. Density given 0.98. Mass by density will give you volume. Volume of the liquid is equal to volume of the vessel. And in that vessel, we are filling gas. So the volume of the gas is volume of the vessel, 0.1 liters. Okay. Yes. Next. Which of the volume temperature plot represent behavior of 1 mole of ideal gas at 1 atm pressure? 1 mole of ideal gas at 1 atm pressure. PV equal to constant. P1 V1 is equal to P2 V2. P1 V1 is equal to P2 V2. You have to verify which will be correct. Which will be correct. You see, volume versus temperature, it has to increase. So this graph you can delete straight away. Now all the other three can be the answer, but you have to verify. How to verify? Oh, it's not P1 V1 equal to P2 V2, sorry. It is V1 by T1. V1 by T1 is equal to V2 by T2. V2 by T2. V1 22.4. T1 273. V2 T2 373. So you take option A. You take option A. 22.4 divided by 273 is equal to V2 divided by 373. See, you have to find out this V2. If V2 is 36.8, option A, 28.6, option B, 30.6, option C. So you find out V2. If you get V2, you get your answer. If you get V2, you get your answer. So what is V2 you will be getting? V2 you will be getting 30.6 liters. 30.6 liters. Appo the answer vera option C. Option C. So apply the equation. Apply the equation. V1 by T1 is equal to V2 by T2. V1 given, T1 given, T2 given, find out V2. See, V2 is the variable. 22.4, 22.4, 22.4, 273, 273, 273. V1, T1 is same. V2 is the variable. V2 is the variable. If you get V2, you get your answer. I think understood. Next question. 2.24 liter cylinder of oxygen at STP found to have developed a leakage. When the leakage was plugged, the pressure of the gas was 570 mm. The number of moles of gas that escaped during the leakage would be 2.24 liter cylinder of oxygen at STP found to develop a leakage. Leakage was plugged, the pressure of gas was 570. So pressure at STP 760 becomes 570. So what is the relation between P and N? That's all. PV equal to nRT. P and N are related. So how will you find out? How will you find out? You see that? PV equal to nRT. P, first case, before leakage, 760. V equal to nRT. Right? So you can find out what is N 2.24 liters. So it is 0.1 RT. 0.1 RT. Hope you understood. Now the second case, it is leaking, and when it is plugged, when the leakage is plugged out, you are getting a pressure 570 mm. So this is the second case. P2 V XRT. So two equations. This is before leakage and this is after leakage. You can get what is X. What is X? X kandupidikam. Because V, RT, everything will cancel. Everything will cancel. What is X? X is equal to 0.075. X is equal to 0.075. What is the question? Number of moles of gas escaped. Number of moles of gas escaped. Initially, number of moles was 0.1. How do you know 0.1? 2.24 liters. 22.4 liters is 1 mole. 2.24 liters is 0.1 mole. So initially 0.1 mole. And now it is 0.075 mole. How much leaked out? 0.1 minus 0.075. It is 0.025. 0.025. Which option? Which option? Option A. I think it is clear. Right? Next. Two glass bulbs A and B are connected by a small tube of negligible volume provided with a stopcock. A contains 100 ml of the gas, but B is evacuated. On opening the stopcock, the pressure of the gas in A is reduced to 40% initial volume. Pressure of the gas reduced to 40% initial value. Volume of glass bulb B is. Volume of glass bulb B is. Apply this. P1 V1 is equal to P2 V2. P1 V1 is equal to P2 V2. P1 you give 100. V1 you give 100 ml. P2 pressure reduced to 40%. So it is 40 into V2. Find out V2. You see, the situation is, this is glass bulb A and is connected through a narrow tube. This is glass bulb B. There was the valve. It was closed and the gas was available here. Now you open it. The gas will be spreading throughout the entire system. So before opening the valve, P1, let the P1 be 100, V1 be the volume of the vessel 100. Now you open it. The gas is spreading throughout the system. And there the pressure is 40. What is the volume? You can easily find out. What is the volume. Right? What is the volume? The volume you are getting 250 ml. The volume you are getting 250 ml. Remember, this 250 ml is the volume of A plus B. The 250 ml is volume of A plus B. Now, upon opening this valve, the gas will spread out throughout. Now the gas is available everywhere. Now the total volume after opening, it is volume of A plus B. That you are getting 250. So what is the volume of B? What is the volume of vessel B? It is total volume 250 minus the volume of A. That is 250 minus 100. 150 will be the volume of B. So V1 P1 equal to V2 P2. P2 is 40% of P. Or straight away, as I said, you can give it like this. P1 V1 equal to P2 V2. You can do it like this. You will get V2 equal to 250 ml. What is this V2? V2 in the, it is A plus B. A plus B is V2. So what is B? V2 minus that of A. V2 is 250. Volume of A is 100. So B will be 250 minus 100, 150. I think it is okay. Next question. At 100 degrees Celsius, 0.1 atm, density of water is 1 gram per centimeter cube, and that of steam is 6 into 10 power minus 4 gram per centimeter cube. Volume actually occupied by water molecules in 1 liter of the steam is. You see, you have steam here. Say 1 liter. Here you have steam. And the density is 6 into 10 power minus 4 gram per centimeter cube. That is 6 into 10 power minus 4 gram in 1 centimeter cube. That is 1 ml. So how much in 1000 ml? So how much gram in 1000 ml? So in 1000 ml it will be in 1 ml this much gram. In 1000 ml it will be into 1000. So it is 6 into 10 power minus 4 into 1000. That will be 6 into 10 power minus 1. That is 0.6 gram. This is the mass of water particle as steam. That is the mass of water particles as steam. Now what is the question? What is the actual volume occupied by water particles? You see, as a steam it is 1 liter. Suppose this is in the form of water. Suppose this is in the form of liquid water. The mass is 0.6 gram. And what is the density? 1 gram per ml. For liquid water density is 1 gram per ml. That means 1 gram 1 ml. Therefore 0.6 gram, it is 0.6 ml. That is 0.6 centimeter cube. 0.6 centimeter cube. Option C. I'll repeat. You have 1 liter vessel in which there is steam. Okay? What is the density of the steam? 6 into 10 power minus 4 gram per ml. So 1 ml, 6 into 10 power minus 4 gram. So 1000 ml, what is the mass? Into 1000. 6 into 10 power minus 4 into 1000. That is 6 into 10 power minus 1, 0.6 gram. So the mass of water particles as steam, it is 0.6 gram. Now what is the question? What is the actual volume occupied by that water particles? Okay. In the form of steam, it is in the 1 liter vessel. Now imagine that steam condenses to get a liquid water. Imagine that steam, 0.6 gram steam, condenses to get the liquid water. It is 0.6 gram liquid water. What is the volume? 1 gram, 1 ml. Density of water is 1 gram per ml. 1 gram, 1 ml. 0.6 gram, 0.6 ml, 0.6 cc, 0.6 centimeter cube. Okay? Fine. Next. Next question. It's a beautiful question. Two separate bulbs contain ideal gases A and B. Density of gas A twice that of B. Density of gas A twice that of B. Molecular mass of A half that of B. Two gases same temperature. Ratio of pressure A to pressure B is. So D is equal to Pm by RT. Apply D is equal to Pm by RT over. D is equal to Pm by RT or P is equal to dRT by M. dRT by M. We want P1 by P2. P1 by P2 is equal to D1 M2 by D2 M1. It is directly proportional to density and inversely proportional to molar mass, while these two are kept constant. So P1 by P2 is equal to D1 by D2 into M2 by M1. Over. What is given there? Density of A is twice that of B. So this is density of A is twice that of B. This is 2, then this is 1. Pinna. Molecular mass of A is half that of B. Molecular mass of A is half that of B. That means if this is 1, this is 2. Molecular mass of A is half that of B. Over. So it is 2 into 2 by 1 into 1. That is 4. Option C. So P is equal to dRT by M. That's all. P1 by P2 is equal to D1 by D2 into M2 by M1. But apply the relations of M1, M2, D1, D2 carefully. Otherwise, there will be a choice. The way you commit a mistake, there will be a suitable choice. Please be very careful. Okay. Next. A gaseous mixture of 2 moles of A, 3 mole of B, 5 mole of C, 10 mole of D contained in a vessel. Assuming that the gases are ideal and the partial pressure of C is 0.5, partial pressure of C is 1.5 atm, total pressure is. You can find out the total pressure when the partial pressure is given. Partial pressure of C is given. So PC is equal to mole fraction of C into P total. This is asked to find out. You can easily work out, no? 1.5 is equal to mole fraction of C. Mole fraction of C. How many moles of C? How many moles of C? Number of moles of C by N total into P total. So it is 1.5 is equal to NC. 2 mole A, 2 mole A, 3 mole B, 5 mole C, and 10 mole D. Over. This is the mole fraction of C. Mole fraction of C will be number of moles of C by total number of moles. That's all. You get what is P total. You get what is P total. Work out. Check whether you are getting 6 atm or not. Check whether you are getting 6 atm or not. Option B. Okay? Simple calculation. Next question. 4 gram argon placed in a bulb at a temperature T Kelvin and a pressure P atm. When the bulb was placed in a bath at a temperature 50 degrees Celsius more than the first. 0.8 gram of gas has to be removed to get the original pressure. The initial temperature is PV is equal to nRT. Apply PV is equal to nRT and identify which are all the variable, which are all the constants. Cancel it and find out. We will work out. You see, PV equal to nRT. What all things are changing? And that is equal to M by mRT. Which are all the constants? Which are all variables? 4 gram argon placed in a bulb at a temperature T Kelvin and a pressure P atm. When the bulb was placed in a bath at temperature 50 degrees Celsius more than the first. So T is a variable. 0.8 gram gas has to be removed to get the original pressure. So mass is a variable. This is a constant, same gas. This is a constant. To get the original pressure, this is also constant. Volume is also constant because it is commented to be in a bulb. So pressure is constant, volume is constant, and only variables are mass and temperature. That's all. Mass and temperature, these two are the variable. So apply M1 T1 is equal to M2 T2. What is M1? 4 gram. 4 gram. What is T1? T. What is M2? 0.8 gram removed to get original pressure. So M2 is 4 minus 0.8, 3.2 into what is temperature? Bulb was placed in a bath at temperature 550 degree more than the first. So the temperature T2 is T plus 50. So 4T is equal to 3.2 into T plus 50. Calculate T. Calculate T and check whether you are getting 200 Kelvin option D. Check whether you are getting 200 Kelvin option D. That's all. Here the variables are mass and temperature. Mass 4 gram becomes 4 minus 0.8. Temperature T becomes T plus 50. Calculate what is T. Okay. Next. Average kinetic energy of an ideal gas per molecule in SI units at 25 degrees Celsius. Average kinetic energy of ideal gas per molecule. How to find out? Per molecule. 3 by 2 kT. 3 by 2 R by Na into T. 3 by 2 R by Na into T. You see that K is equal to 3 by 2 kT. What is K? K is R by Na. R by Na. So 3 by 2 into R into T into divided by Avogadro constant. So 3 by 2 into R value, T value and N value. Okay. You can verify to get 6.17 into 10 power minus 21 option A. For 1 mole of gas, 3 by 2 RT. For N moles of gas, 3 by 2 nRT. For 1 molecule of gas, 3 by 2 R by Na. I am sure you remember R by Na K. That is called a Boltzmann constant. Boltzmann constant. Fine. Next question. A mixture of 3 gases A, B, C has a pressure 10 atm in a liter vessel. The total number of moles is 10. If the partial pressure of A, B are 3 and 1, and if C has molecular weight 2, what will be the weight of C in gram per liter in the mixture? That is the question. A mixture of 3 gases A, B, C, pressure 10 atm. Pressure 10 atm in a liter vessel. In a liter vessel. Total number of moles is 10. Total number of moles is 10. Total pressure is 10. Partial pressures 3, A and B are 3 and 1. So you see that total pressure is 10 equal to PA plus PB plus PC. PA 3, PB 1. Then what is PC? PC will be 6. This is PC. Now, partial pressure and the number of moles will be directly related. See, it will be directly related to number of moles. So, moles are 316, total pressure 10, total number of moles also 10. So, that number of mole ratio will be same, 3 plus 1 plus 6. This will be the number of moles. Number of moles will be same. Pressure contribution will be directly coming as the mole contribution because total pressure 10. Contribution of pressures 3, 1 and 6. So what is the mole contribution? Same, 3, 1 and 6 because number of moles also 10. So the pressure, see the number of moles of C will be 6. What is the weight of C in gram per liter? Weight of C in gram per liter. There is 6 mole per liter. See, it is a 1 liter vessel. 6 mole per liter. Molecular weight of C is 2. Therefore, mass will be number of moles into molar mass. Number of moles is 6. What is the molar mass? 2. So, what is the mass? 12. 6 into 2. 6 moles into 2 will be the answer. I think it is clear. So, AB pressure contribution given, total pressure given. So, you get the pressure of C. Total number of moles are given. Looking at the pressure contribution, you can find mole contribution. So, moles of C we can get same 6. Then mass will be 6 into molar mass, 12. Okay, next question. Unit of A in van der Waals equation of state is, you see, correction pressure is equal to AN square by V square. So what is A? A is equal to P into V square by N square. That is P ATM. ATM liter square per mole square. ATM liter square per mole square. You know the correction pressure. Correction pressure is equal to AN square by V square. So what is A? It is P V square by N square. P the unit ATM volume liter square by mole square. ATM liter square by mole square. Next. An open vessel at 27 degrees Celsius heated until 3/5 part of air in it has been expelled. Assume that the volume of the vessel remains constant. The temperature to which the gas has been heated is. An open vessel, 3/5 expelled. 3/5 expelled. So 2/5 remaining. 2/5 remaining. So what the variables are? Number of moles and temperature. What the variables are? Number of moles and temperature. Or even you can apply in the volume condition also. Either you can apply N1 T1 is equal to N2 T2, no problem. Or V1 by T1 is equal to V2 by T2. What is V1? 1. What is V2? 2 out of 5. Because 3 out of 5 expelled. 3 out of 5 expelled. What is T1? 300. What is T2? You will get 750 Kelvin. 750 Kelvin. Convert into degrees Celsius. Convert into degrees Celsius. Okay. Or you can do it like this. N1 T1 is equal to N2 T2. Right? 3/5 expelled. 3 out of 5 expelled. So it is 5 into T1 is equal to 2 into T2. 5 into T1 is 300 is equal to 2 into T2. You can find out T2. You can find out T2. You will get 750 Kelvin. Same data you will get. Okay. How I put 5 and 2? How I put 5 and 2? If initial is 5, 3 out of 5 expelled. So remaining is 2. 3 out of 5 expelled. So initial 5, final 2. Okay. Next. A mixture of ethane and ethene occupies 41 liter at 1 atm 500 Kelvin. Mixture reacts completely with a 10 by 3 mole of O2 to produce CO2 and H2O. The mole fraction of ethane and ethene in the mixture are. Mole fraction of ethane and ethene in the mixture are. A typical question from the chapter. Let's see. See, first we can find out the number of moles of the mixture. How to find the number of moles of the mixture? PV by RT. What is pressure? 1 atm. Given? Yes, 1 atm. V 41 liters. V 41 liters. R and temperature. Temperature given, you get 1 mole. You get 1 mole. Now, let X moles of ethane, then 1 minus X moles of ethene. X moles of ethane and 1 minus X moles of ethene. Now you see, this is the combustion reaction of ethane. And this is the combustion reaction of ethene. Okay. Now you see, 1 mole produces, mixture reacts completely with the 10 by 3 moles of oxygen. You see, 1 mole requires 7 by 2 oxygen. Therefore, X mole requires 7 by 2 into X. Oxygen required here is 7 by 2X. Now, 1 mole require 3 mole oxygen. Therefore, 1 minus X mole require 1 minus X into 3. So, this is the oxygen requirement in 2 cases. In the first case, oxygen required is 7 by 2X. Second case, oxygen required is 3 into 1 minus X. And that is equal to 10 by 3 given in the question. Now you can get X. You can get X. X ആണ് ചോദ്യം. Sorry. X and 1 minus X is the question. The mole fraction of ethane and ethene. Ethane you are getting 0.67. Therefore, ethene will be the remaining. Answer is 0.67 and 0.33. Option C. For the combustion of 1 mole ethane, you need 7 by 3 mole oxygen. For X mole ethane, you need 7 by 3 into X. For 1 mole ethene, you need 3 mole oxygen. For 1 minus X mole ethene, you need 3 into 1 minus X mole oxygen. And when you add, it is as given in the question 10 by 3 oxygen. So you can get X and 1 minus X. Okay, next question. A bubble of gas released at the bottom of lake expands to 8 times its original volume on reaching the surface. Assuming that atmospheric pressure is equivalent to pressure exerted by a column of water of height equal to 10 meter, depth of the lake is. You see, this is the bottom of the lake and this is the top of the lake. You had a bubble here. It is traveling to top. The volume reaches 8 times. Here it is 1 ml means here it is 8 ml. So volume increases by 8 times. Therefore, pressure decreases. Volume increases. Quite naturally, pressure decreases by 1 by 8. From bottom to top, pressure will decrease by 1 by 8. Or I can tell you the reverse. From top to bottom, pressure increases by 8 times. You see, from bottom to top, volume increases by 8 times. So quite naturally, from top to bottom, pressure increases by 8 times. Isn't it? Isn't it? Here pressure is 1 atm. Here pressure is 8 atm. And it is commended to be 10 meter. It is commended to be, assuming that atmospheric pressure is equivalent to pressure exerted by column of water of height equal to 10 atm. That means it is given 1 atm is equal to 10 meters. Given in the question. 1 ATM equal to 10 meter water column. What is the depth of the pond? 1 ATM equal to 10 meter of the water column. What is the depth of the pond? There is every possibility that you say an answer 80 meters. Answer is 70 meters. You see, 1 to 80 meter, 1 to 8 ATM, 1 ATM 10 meter, 1 ATM 10 meter. It is given 1 ATM 10 meter. There is a possibility you wrongly commit the answer option A. The answer is option D. Because 1 ATM 10 meter water column. It is 1, 2, 3, 4, 5, 6, 7. This is 10 meter. This is 10 meter. This is 10 meter. 10 meter. 10 meter. 10 meter. 10 meter. 1 to 8. How many divisions? 1 to 8. How many 10 meters? 7. So it is 70 meter. Okay. The depth of the pond is 70 meter, option D. Next. Pressure of a gas A at 27 degrees Celsius 2 bar. When 2 gram of another gas B introduced in the same flask at the same temperature, the pressure becomes 3 bar. The molecular mass of the gas is. So it is pressure, mass and molar mass. That is the relation. So P proportional to M by M. P proportional to M by M. That's all. You see that PA by PB is equal to PA by PB is equal to mass A by mass B with the MA/MB. You see that? WA by MA into MB by WB. That is a relation. Because PV is equal to M by M RT. These two are the variable. So P proportional to M by M or W by M or W by M. So PA by PB is equal to WA by WB, MB by MA. Just to substitute the conditions. Just to substitute the conditions given. Pressure of 1 gram of gas is 2 bar. When 2 gram of another gas B introduced in the same flask at the same temperature, pressure becomes 3 bar. So P1 is 2 bar, PA 2 bar. What is PB? What is PB? The total pressure becomes 3 bar. Already it was 2 bar. When the new gas came, 3 bar. So what is the pressure of the gas B? 3 minus 2. So it is 1 bar. So PB is 1 bar. WA 1 gram. WB 2 gram, another gas introduced, 2 gram. So this is known, this is known, this is known, this is known. You have to get a relation between these two. You will get MB is equal to 4 times MA. MB is equal to 4 times MA. So there was a gas 1 gram, gas A. Pressure 2 bar. So PA 1. PA 1. Mass A 2 gram. Now, isn't it 2 gram? Sorry. PA 2 bar, mass A 1 gram. PA 2 bar, mass A 1 gram. Now you are introducing another gas. How many grams? How many grams? 2 more grams. 2 grams. And now the pressure nu is 3 bar. So what is the pressure due to B? Already there is 2 bar pressure. What is the pressure due to B? 3 minus 2. 1 bar is the pressure due to B. Now we have PA, PB, WA, WB. Find out the relation between MA and MB. Okay, next question. Relationship between PC, BC, TC. Relationship between PC, BC, TC. All of you know this is TC, critical temperature 8A by 27 RB. PC, A by 27 B square. BC, 3B. Now apply that and find out PCBC is equal to 3 by 8 RTC. Option D. You can easily work out. You can easily work out. If you know the relation for critical parameters, critical temperature TC, critical pressure PC, critical volume VC. If you know the relations, you can easily derive. What is the relations? Critical temperature 8A by 27 RB. Critical pressure A by 27 B square. Critical volume 3B. Now apply the relations. Apply the relation between the three and find out what is PCBC. Okay. Next. Twenty-sixth question. 5 gram nitrogen, 96 gram oxygen mixed isothermally to get a total pressure 10 atm. Partial pressure of oxygen and nitrogen are respectively. Partial pressure of nitrogen and oxygen are respectively. Total pressure given, masses are given. Find out. Partial pressure of nitrogen is equal to mole fraction of nitrogen into total pressure. This is given. This you need to find out. This you can calculate. So find out number of moles. Find out number of moles of oxygen. Number of moles of nitrogen 56 by 28, 2 mole. 56 by 28, 2 mole. Number of moles of oxygen 96 by 32, 3 moles. Over. So it is 2 by 5 into 10. You are getting 4. So the answer is partial pressure of oxygen and nitrogen. Nitrogen 4, therefore oxygen will be 6. So it is option D. Don't confuse with option A and D. So number of moles of nitrogen 2 mole. Number of moles of oxygen 96 by 32, 3 mole. So partial pressure of nitrogen, mole fraction of nitrogen into total pressure, mole fraction 2 divided by total 5, 2 into 5, 2 by 5 into 10. So you are getting 4. That is nitrogen. Therefore, partial pressure of oxygen will be 6 because the total is 10. So it is 6 and 4. Option D. Van der Waals parameter for some gases are given below, which has highest critical temperature. Once again, Tc is equal to 8A by 27 RB. That means Tc proportional to A by B. Higher the A by B value, higher the critical temperature. Higher the A by B value, higher the critical temperature, which will have higher A by B value. Hey, at once you can find out. It is Z. Option D. You see that? 12 by 0.027. Option D is the correct answer. 12 by 0.027. Next question. Molecular velocities of two gases at the same temperature are U1 and U2. Their masses are M1 and M2 respectively. Which of the following expression is correct? Molecular velocity is directly proportional to temperature and inversely proportional to molar mass. Molecular velocity of the same temperature. That means proportional to root of m only. So it is U1 by U2 is equal to root of M2 by M1. That is U1 square by U2 square is equal to M2 by M1. That is M1 U1 square is equal to M2 U2 square. M1 U1 square is equal to M2 U2 square. Okay, option D. Next. Equal masses of SO2, methane, oxygen mixed in an empty container. When total pressure is 2.1 atm, the partial pressure of methane is equal to mole fraction of methane into total pressure. What is the mole fraction of methane? We are taking equal masses of the gases. Imagine I am taking 64 gram. All 64 gram. This will be 1 mole. This will be 4 mole. This will be 2 mole. I am taking 64 gram. This. 64 gram SO2, 1 mole. 64 gram CH4, 4 mole. 64 gram O2, 2 mole. Why? SO2 is molar mass 64. 64 gram, 1 mole. Methane, molar mass 16. Number of moles, 64 by 16, 4 mole. Oxygen, 32. 64 by 32, 2 mole. Over. Mole fraction of methane. Number of moles of methane divided by total number of moles. 4, 5, 7. 4 by 7 into 2.1. 7 with the 2.1. It is 0.3 times. 4 into 0.3. 1.2. Option C. Okay. Next. That is the last question, I believe. The correct expression for van der Waals equation of state. P plus an square by v square into v minus nb is equal to nRT. All of you know. P plus an square by v square into v minus nb is equal to nRT. Eda? P plus an square, this is out. P plus an square b square delta nRT, it's out. P plus an square by, this is the answer. Here what is the problem? P plus an square by v square, n is missing. So it is option C. Option C is the correct answer. P plus an square by v square into v minus nb is equal to nRT. Right? So these are some typical questions what we have discussed from States of Matter, the chapter 5. We will meet in another class, another chapter, few more very beautiful questions. Okay, dear children. Bye then. See you. Take care.